quantities described by equivalent ratios. Think about this question during the lesson. On Shina's favorite mobile game, she is awarded game lives when she finds gold coins. She wants to know how the number of game lives awarded is related to the number of gold coins she finds. Shina and her friends Marcus and Olivia love to play Treasures of Soltar on their phones. Shina has 3 rare gold coins. In the game marketplace, she can trade 3 gold coins for 9 game lives. You can write a ratio that relates the number of gold coins found and the number of game lives awarded. You can organize this information in a table. Three coins, 9 tokens, for a ratio of 3 to 9. Marcus has 2 gold coins. He can trade them for 6 game lives. This time, the ratio is 2 to 6. Olivia has 5 gold coins. She can trade them in for 15 game lives. 5 coins, 15 game lives, a ratio of 5 to 15. What are some other ways you could model this problem? Now we need to use the definition of proportional relationship. 2 quantities are in a proportional relationship if all of the ratios that relate those quantities are equivalent. In this case, the quantities are gold coins and game lives. Shina and her friends have 3 ratios. She can use the definition to figure out whether they represent a proportional relationship. Notice that the ratio 3 to 9 is equivalent to 1 to 3. 2 to 6 is also equivalent to 1 to 3. The same is true for 5 to 15. The ratios are equivalent. 1 to 3, 1 to 3, 1 to 3. This means that for every gold coin Shina finds, she gets 3 game lives. The table shows 3 equivalent ratios, so the number of game lives awarded is proportional to the number of gold coins found.
Alejo records the time it takes to download a variety of file types. How is the download time related to the file size? Explain. The ratios for each pair of data are, so the download time and the file size are.
So we look here at our table, and here it shows us the type of media, file size, download time over the file size. So the ratios for each pair of data are, and so we have file size for the document is 1.25 or 1 in 25 hundredths. The time is 25. So they have download time over file size. So what that means is that 25 was on top, and then on the bottom we should have the file size, which is 1 and 25 hundredths. And so for song, the file size is 3.6 or 3 and 6/10, which is here. And then the time is going to be on the top as 72. Video size is 6 and 25 hundredths. And then we have 125 as the download time. And then they have us find out what it is equal to. And we're just going to do this on the side so you can see. You take your denominator and you divide it into your numerator. because we have a decimal, in our divisor, we have to move that over, and then we have to move it over here. And so now we have 625 into 125. And so 625 cannot go, not into 125, I'm sorry, into 12,500. So that would equal 625 times 2 is equal to 1,250. Then we bring down that 0, and then 625 can go into 0 times. So let me just write it up here. That'll be 20, and that's 0. And our answer will be 20 after we simplify that there. So if you notice, for each one, there's a 20 after they simplified it. And so the ratios for each pair of data are, excuse my handwriting, but 25 over 1 and 25 hundredths, 72 over 36 hundredths, 125 over 625 hundredths. And so the download time and the file size are proportional. And that's it.
Is the relationship between the area and the side length of the squares proportional? Explain your reasoning.
Step 1, make a table to organize the data. Find the ratio of area to side length for each data pair. Click on each row to see a visual representation. So we have here is that representation. You have 2 by 2. So the area of that is 4. And then you see the area over the side length. For 3 is the side lengths. You have the area of 9, and then it shows you the ratio of that as well. And then for 4, you have this model here, and it shows you the ratios for that one. Step 2, compare the ratios by finding the unit rates. Because 2 over 1 is not equal to 3 over 1, that is not equal to 4 over 1. The ratios are area over side length. So area represented by y over the side length of x. For the 3 squares are not equivalent. The relationship between the area of the side lengths is not proportional. And so unit rates, just to clarify, is any fraction ratio over 1.
The table shows the side lengths and perimeters of regular hexagons. Is the relationship between the perimeter and the side length of the hexagons proportional? Explain.
So we have to look at the ratios of the side length and perimeter. So we will write the perimeter, because in the example they showed us that it was y over x. So our y for this one will be 12, and then it'll be x will be the 2. And then we have for the next one 18 over 3. And then we have to compare if they're equivalent. So we can simplify these by dividing by their greatest common factor. So the greatest common factor of 12 and 2 would be, we have to look at the unit rate. So 12 divided by 2 actually will give us 6, right? And then 3 divided by 8 is 6. So if we were to compare them to say if they were indeed proportional, then in this particular case the answer would be yes, because they are equal. And just if this was written as a unit rate, just because we talked about that in the example, that would be 6 over 1, and 6 over 1. So they both have 1 as the denominator and 6 as the numerator, which makes them proportional.
A proportion is an equation that represents equal ratios. Use the table at the right. How many times will a hummingbird beat its wings in 60 seconds?
Step 1, verify that the quantities are proportional. So we have our seconds and wing beats. And so the first set is 160, so wing beats over the seconds. And then the second one, wing beats over the seconds. So we have all of our quantities listed as a fraction. And then when you simplify them to the unit rate, this is what they equal. And because they are all equal to the same unit rate, the ratios are equivalent, and so the quantities are proportional. Step 2, write and solve a proportion. So 80 over 1 is equal to y over 60. Remember, that's wing beats, y. Because x and y are proportional, every ratio y over x is equivalent to 80 over 1. So 80 over 1 times 60 is equal to y over 60 times 60. So we're multiplying both sides by 60 so we can get our y. So 4,800 is equal to y once we simplify. And a hummingbird beats its wings 4,800 times in 60 seconds.
Nala's favorite cookie recipe requires 1 1/2 cups of sugar to make 24 cookies. How much sugar does Nala need to make 36 of these cookies?
Okay, so Nala's favorite cookie recipe is 1 1/2 cups, and she needs 24. So then we take the 1 1/2 cups of sugar and the 24 cookies. That is equal to 24 cookies. So now we're going to take that 1 1/2, put it over 24 cookies, so we create our ratio is equal to 36, and then we have to multiply that 1 1/2 over 24 and 36. So we're going to multiply by 36, and so 36 times 1 1/2 is equal to 54, and then 24 times nothing, or over 1 if you want to look at it that way, is 24, and then we have to simplify that. So then let's simplify. And this is equal to 2 1/4 cup of sugar, cups for 36 cookies.